Have you ever wondered if we are alone in the universe? A question as old as humanity itself, and yet it continues to captivate our collective curiosity. Let's take a moment to appreciate the sheer magnitude of our universe. Picture billions upon billions of galaxies, each one a dazzling array of stars. Now consider that each of these stars is a sun, potentially orbited by a multitude of planets. Some of these planets reside in just the right spot, a habitable zone, where conditions could be just right for life as we know it. It's a zone not too hot, not too cold, where liquid water, the elixir of life, might exist. And if water can exist, well then so might life. It's a staggering thought, isn't it? The possibilities for life, even intelligent life, are virtually limitless. Given the unfathomable scale of the universe, isn't it possible that somewhere out there, life exists? If the universe is so big and the conditions for life could exist elsewhere, why haven't we encountered extraterrestrial life yet? This is the question at the heart of what we call the Fermi Paradox. The Fermi Paradox is a scientific enigma that probes the contradiction between the high probability of existent alien life and our lack of contact or evidence of such. It's named after the renowned Italian physicist Enrico Fermi, a key contributor to the development of nuclear energy. The story goes, one sunny afternoon in the summer of 1950, Fermi, while having a casual chat with his colleagues at Los Alamos National Laboratory, suddenly blurted out, "Where is everybody?" This seemingly simple question, asked over 6 decades ago, has since become a central debate in the realm of astrobiology and set theory. Fermi was referring to the paradoxical situation that arises when we consider two facts. First, the sheer size and age of the universe suggests that there should be many technologically advanced civilizations out there. With hundreds of billions of stars in our galaxy alone, and even more galaxies in the observable universe, it's almost unimaginable that Earth is the only planet where life has arisen. Second, if there are a significant number of such civilizations, it would be expected that we would have already had some form of contact with them, either through their visits to Earth, radio signals, or other means. Yet, despite all the efforts to find extraterrestrial life, we have found no evidence, no signals, no visitors. Hence, Fermi's question, where is everybody? The Fermi Paradox doesn't provide an answer. Instead, it presents a problem, a puzzle that scientists and thinkers have been trying to solve for decades. It's a question that forces us to confront the possibility that we might be alone in the universe, or perhaps that we're just not looking in the right way or at the right time. The Fermi Paradox poses a perplexing contradiction between the high probability of extraterrestrial life and the lack of contact or evidence. To better understand the Fermi Paradox, we need to break it down into its key components. The first component is the Drake equation, a mathematical formula created by astrophysicist Frank Drake in the early 1960s. This equation is not designed to provide a definitive answer, but rather it's a probabilistic argument used to stimulate scientific dialogue. The Drake equation estimates the number of civilizations in our galaxy with which humans could potentially communicate. It considers factors like the rate of star formation, the fraction of stars with planetary systems, the number of planets that could support life, and the likelihood of life developing into intelligent beings capable of interstellar communication. So, according to the Drake equation, there should be a multitude of civilizations out there in the cosmos, just waiting for us to dial them up. But wait, if there are so many potential civilizations, why haven't we had a cosmic conversation yet? This brings us to the second component of the Fermi Paradox, an aspect often referred to as the Great Silence. This concept points to the contradiction between the high probability of extraterrestrial life as predicted by the Drake equation and the conspicuous lack of evidence or contact with such civilizations. We've been listening to the stars for decades, but so far, space has remained eerily quiet. Despite our best efforts and technological advancements, we've yet to detect a single extraterrestrial signal or find any tangible evidence of other civilizations. The universe, it seems, is giving us the silent treatment. This great silence is both baffling and intriguing. It's like having a phone with countless potential numbers to call, but when you dial, there's no answer, not even a voicemail. This contrast between what we expect and what we observe is the crux of the Fermi Paradox. Some might argue that our technology is still primitive, that we're like a toddler trying to tune into a frequency meant for a sophisticated radio. Others suggest that perhaps we're not alone, but we're isolated, like a lone island in the vast cosmic ocean. Maybe our messages are lost in the cosmic static, or perhaps the aliens are simply choosing not to respond. The Fermi Paradox is a cosmic conundrum that encourages us to question our place in the universe. It reminds us of our solitude in the cosmic arena, while simultaneously hinting at the tantalizing possibility of cosmic company. As we delve deeper into the cosmos, we continue to grapple with the Fermi Paradox, fueling our curiosity and driving our quest for knowledge. Whether we are alone or not, the search for extraterrestrial life is a journey of discovery, a testament to our unquenchable thirst to understand our place in the universe. These two components together highlight the paradoxical nature of our search for extraterrestrial life. The Fermi Paradox has sparked numerous hypotheses attempting to explain this cosmic silence. First up, let's consider the idea that advanced civilizations might be intentionally avoiding contact. This is known as the zoo hypothesis, suggesting that Earth might be something akin to a nature preserve, watched from a distance but never disturbed. Imagine how we humans observe wildlife without intervening in their natural processes. It's possible that advanced extraterrestrial civilizations are doing the same with us, allowing us to evolve and develop without their interference. Then there's the self-destruction hypothesis. It suggests that any civilization that reaches a certain level of technological advancement inevitably destroys itself. This could be through warfare, environmental destruction, or some other catastrophe of their own making. If this is true, it would mean that the universe is a graveyard of civilizations that were too successful for their own good. Another popular explanation is the hibernation hypothesis. This theory proposes that advanced civilizations are not gone, but dormant, waiting for a more favorable time in the universe's lifespan. It's like how certain animals hibernate during the harsh winters, waiting for the warmer, more abundant spring. These civilizations could be waiting for a future era of the cosmos, where conditions are more conducive to their existence or their goals. Then there's the possibility that we are simply not listening properly. Our methods of searching for extraterrestrial intelligence are based on our own understanding of technology and communication. We look for radio signals because that's what we would use, but an advanced civilization might use a completely different form of communication that we don't know about or can't detect. It's like trying to listen to a conversation in a language you don't understand. You hear the sounds, but you can't make sense of the words. And of course, we can't forget the idea that we might be alone. As chilling as it may sound, it's possible that we are the first, the only, or the last civilization in the vast cosmos. This is known as the rare Earth hypothesis, suggesting that the specific conditions needed for life as we know it are so rare that we might be a unique occurrence in the universe. These are just a handful of the many hypotheses that try to explain the Fermi Paradox. Each one is fascinating in its own right, and each one brings up more questions than it answers. Some of these theories might sound like science fiction, but remember, reality is often stranger than fiction. While these explanations are fascinating, none have provided a definitive answer to Fermi's question. Why does the Fermi Paradox matter to us? What significance does it hold? These are the questions that naturally spring to mind when we delve into this cosmic conundrum. The Fermi Paradox is not just a thought experiment or a mere philosophical musing. It holds a profound, pivotal place in our quest to understand our place in the cosmos. The paradox serves as a catalyst, sparking our curiosity and driving us to push the boundaries of our knowledge. It is a reminder of the vastness of the universe and the endless possibilities it harbors. It encourages us to question, to explore, to seek. The Fermi Paradox is a testament to our unyielding pursuit of truth, our insatiable curiosity about life beyond our pale blue dot. It is a beacon illuminating our path as we voyage into the unknown, in search of our cosmic neighbors. The Fermi Paradox reminds us that we still have much to learn about the universe, and that the search for extraterrestrial life is a quest that is far from over.